parabolic motion. And now I want to know how far away does it land from the cliff. I want to know that distance, x or d. Whatever you want to solve for. So is my question dealing with a horizontal problem or a vertical problem? It's dealing with a horizontal problem. So let's identify what I know from my horizontal direction. Initial velocity? Final velocity?
Well, it's 0.
We'll talk about that in a second. Acceleration? It's not 9.8, because 9.8 is gravity. It's acting up and down. What's the acceleration in the y? 0. There's nothing pushing it. There's nothing accelerating it in the x direction. So this acceleration is 0 meters per second squared. In the x direction, it will always be 0 meters per second squared. In the y direction, it will always be 9.8 meters per second squared, unless we're on a different planet. What else? Change in position. Do we know it?
No.
No. And time? That's a different problem. Do we know the time though? No. That's a good point though. Can we solve for time?
Yes.
Yes, we can. We just did it in the previous problem. So it's not 2.86, but it's easily solvable here. What's the final velocity? Well, before it hits the ground, like just instantly before it hits the ground. 4 meters per second. Because there's no acceleration, so we're not going to change. Now that piece of information is basically useless. The fact that it remains at 4 meters per second doesn't help you. And let me show you why. Let's say that, oh, I know a lot of that stuff, so let's try to use this equation to solve for how far I went, because I know all of those pieces of information. Well, final velocity meters per second squared equals initial velocity meters per second squared plus 2 times a delta d. Well, 4 minus 4, that's 0. 0 minus everything is 0. That's worthless stuff. We already know that 0 equals 0, I hope. So final velocity, really not a helpful thing to know. So we need to find time. Right. So this one we can't really even use as an equation. So we only know 2 pieces of information. We need to find out the third. So time, like I mentioned, is the combining factor. How do I solve for time? We have to use the y-axis. So we cannot use this information to solve for time. We have a new set of information. Y values. Y values, initial velocity? 0 meters per second. Change in position. Negative 75 meters. Acceleration. Negative 9.8 meters per second. That's 3 pieces of information we can solve for time. And we solve for it just like we did in the previous problem. Change in position is the t plus 1 half. Negative t squared. Negative 75 meters equals, that's 0. Okay. So time in the y, 3.9 seconds. Is that the same time as it is in the x? Yes, it is. If it takes 3.9 seconds to get to the ground, at 3.9 seconds, it's at the ground. So there's no way it can go any further left or right after 3.9 seconds. So it takes the same amount of time to get down as it does to get here. So at 3.9 seconds, we are at the ground. That's how far we went. So now I can use that piece of information, 3.9 seconds. Now do I have three things? Yes, I do. So then I will use the x direction to solve for how far we went. Changing d, d at t, plus 1/2 kt squared. Same equation, but now different values. Only now from this column. X. Changing d. That's what we're looking for. Initial velocity, 4 meters per second in the x times the time, 3.9, plus 1/2 the acceleration, 0. And whatever that, doesn't matter, this is 0. The change in d is equal to 4 meters per second times 3.9 seconds. And d is equal to 60. 0.6 meters. Takes a little more organization for these problems. You can't go into it saying, oh, this is going to take forever, or this is a really hard problem. It's basically what we did in free fall, horizontal motion, but twice. Once in the x, once in the y. Any questions? We'll do one more example, and I'll let you do this one on your own to see where you stand. And then, that's it. Ball traveling 10 meters per second. $35 meters on the x. How high is the cliff? There's clearly a vertical problem. Initial velocity is 0.